Hey, Honors Cam. Many of you carry around keys that look like this, where it's brass or copper underneath, and it has a shiny coating on the outside. So today we're going to take a look at how and why we would want to do something like that, um, and how much electricity is needed to do something like that. So we have a lot of metals that have nice properties but aren't perfect. So we have pretty metals, we have strong metals, and we have expensive metals. So sometimes it's nice to plate a coating of one metal on top of another, either putting some shiny gold on that copper necklace, or in the case of my truck key, putting some shiny chromium on top of a brass or steel key. It makes it cheaper, it makes it prettier, it's usually corrosion resistant, and it's done through a process called electroplating, where we just put a thin coat on by chemically reducing it to a pure metal on that substance, whatever you're trying to plate. So it's set up kind of like this. That's my key. We're going to use a battery or some type of electrical current to push the electrons. So depending on what substance you're trying to plate, what you're trying to plate it on, this is going to be our anode, okay, where oxidation occurs. So say we're trying to plate this key with copper. This is going to be a piece of copper. We are going to reduce these copper atoms to copper ions, either +1 or +2, depending on temperature and things like that. And then this is going to be our cathode. Okay, red cat, reduction happens at the cathode, and these copper ions are going to be plated on the key as a pure layer of copper. It's going to get slightly larger, and it's going to get that coating of copper metal on the key. Oxidation is loss of electrons. So when this copper loses its electrons, the ions are going into solution. The electrons are lost to the wire. Okay? Reduction is gain. The electrons are gained by these ions and plated onto the cathode. And these electrons can then be pushed with our power source. So that's how electroplating works. We're going to take a little bit of a look at how much electricity and how much stuff we can plate based off of that. One more concept before we do that. You can do electroplating or what's called electrorefining. Electrorefining, you will literally refine an impure metal. So this is done usually with very precious metals because it takes a lot of electricity to do this, and it's only something that's worth a lot of money that's worth doing this. This is also why Canada has the best gold in the world. They will use an impure piece of gold cathode, and they will electro-refine it. So as this is oxidized to gold ions, and they will electro-refine atom by atom all the gold that their country produces in the mint. Anything that's not gold then kind of forms on the bottom here as a sludge, or is just not reactive enough to be oxidized. So electrorefining, electroplating, using the same type of concept there, just a longer period of time. So they plate all of their gold as pure. we can take a look at how much electricity this requires using a concept called coulombs. And a coulomb is defined as an amp times seconds. So those of you who know anything about electricity, an ampere or an amp is kind of the push of electricity. That's your current in a system. So we can measure the amps, we can measure how long we're running one of these electrochemical cells, and measure the coulombs required to plate the metal. The conversion then, 96,500 coulombs will move 1 mole of electrons. Okay. Then it just becomes a stoichiometry problem. So if we set up an electro refining or an electroplating cell, let it run overnight, then you can take your average current times the number of seconds to get coulombs and figure out what mass of metal should be plated at the cathode. So these are not too difficult problems because, once again, it's just stoichiometry after you calculate coulombs. That should help you with the homework, and that's electroplating and refining. Have a good one.